Yep. Oh boy. So what are we doing today? So we need to pour some coffee. That's what we need to do. We need to pour some coffee. How much did that coffee grinder I bought my parents cost? That much? Oh, it was pretty expensive, dude. I don't want to pay for that. That's a bit much. Oh boy. Why is this like the mobile site? There's a hand grinder. I mean, honestly, I don't think you really need a grinder with a motor. Fuck you, Shammy. You're just gonna sit there, I don't care about your experience. So. What we need to do is... this, the voxel data. That needs to be changed. Right now we just have a color index and a brick index. So it goes like that. I wanted them to be arrays, but you can't do arrays. I have to do like special bullshit to get an array in there. I don't really. I'm just not really sure what I'm even doing here. Struct, let's make the I just want to avoid calculations as much as possible, because what I'm doing right now, for example, is basically every single step of the way that we go through the voxels, we do a check voxel. And that means doing modulo, modulo, multiplication, modulo, multiplication, division, division, multiplication, division, multiplication, multiplication. And then we go in here and we do a division, we do a floor, a conversion, conversion, multiplication, and then a bit shift. And I would like to just avoid doing all of this shit as much as possible. Hello, Keb, how's it going? Play any good VNs? Play any Dota recently? Make any bitcoins? Yeah. If I'm gonna be perfectly honest, the two reasons I don't play MOBAs is because I just seethe so hard. Like, I get so mad, it's absolutely unreasonable. And the second part is I just don't enjoy the metagame in them. It's like playing Smash at a high level. Like, Smash is fun when you're both like beginners, and then when both people know how to play Smash, it's like the worst game ever. It's just not enjoyable when you're playing at a high level, in my opinion. But yeah. Just micro, like just be a 1v1 game. You just have 5 heroes, and then it's just a micro game. I don't know if that would be enjoyable either, but I mean, there could definitely be a way to go about it. But and also, when I still had friends, playing MOBAs with friends it was like the worst thing for everyone's relationship. Like everybody just started hating each other. Like everybody just hated everybody when we were playing. Like, if even one person is not good enough and they don't put enough effort into learning the game and getting good at it, they just should just not be allowed to play with the friend group. Like, otherwise it's just gonna... Honestly, game quality is probably best in North America. But I don't know if you play on the same servers. Like, either that or Korea or something. Because Europe is terrible. Like, Europe is one of the worst places to play online games. The problem with North America is that Americans... Like, you've got Brazilians. You guys are the worst. I don't know what you're talking about with the Peruvians. Brazilians are the worst, by far. And then you have some random other dudes that don't speak English. And then just Americans themselves are like the whiniest fucking piece of shit on the planet. Like, they're so whiny. Americans are one of the whiniest people on the planet, by far. But in Europe, we've got the French, and we've got the Germans, and we've got, like, basically any Middle Europe country. Like, they still don't speak English. The Italians, they don't speak English. The Finnish barely speak English. The French don't speak English. Germans don't speak English. Spanish don't speak English. Russians are the best people. Like, it's weird. There's like two classes of Russians. There's like Russians who know English are really good gamers. But then Russians who don't speak English are like the absolute worst gamers. There's something about knowing English in games that have like buttons and stats and abilities that do things, I guess. That might be vital. But like the French are the worst in Europe by far. Yeah. See, when you're playing Final Fantasy XIV and you queue for a dungeon, if you then, because you can see then which languages they prefer. If it says E, F, G, or J for Japan, if it says F, without fail, they will be so bad. Like, it's absolutely unreal how bad they are. Like, they literally cannot manage to play a DPS in an MMO. Like, if you can't DPS in an MMO, then I don't know what's wrong with you. Well, honestly, it all boils down to who can't speak English online. Like, if they can't speak English, then you just can't play with them. And some countries just have less people who speak English. Brazil is one of those. And that's just how it is. I don't know how it is in your generation, but in my generation, people all over the world did not speak English. I was in a WoW guild with it was a Finnish WoW guild, because I had one Finnish friend in there, and he was like, "Come play WoW with us," and I was like, "All right." And there were like 20 people, and he was the only one who spoke English, out of every single other Finnish 14 to 20-year-old. Like they couldn't even stumble through a sentence in English to like kind of make themselves understood. Like they could not do even a little bit. It's not a Finnish thing. It's just how things were. gaming and like online movie torrenting is like the only thing that has brought most of Europe into English. Before that, they did not speak English. Even now, Germans don't speak English, and that's because everything that they have is dubbed. So Germans and French people, they dub everything, and that's why they are now the worst people in Europe at English. Like, everyone else is catching up. Even like Latvians and shit. But Germans, they just straight up don't. And the Spanish. I don't know. Like, Spanish... Everybody speaks Spanish. So... I guess everything also gets translated into Spanish. So Spanish people, they just kind of isolate themselves into the whole Spanish media sphere. And then they don't have to give a shit either. Because they're... I think people who have like Spanish origins are probably some of the worst people. Yeah, that's what I mean. Because when I was helping out moderating the Ace Bright channel and like helping people with problems, the only people who came in who were like, "Do you speak this language?" were Spanish people. Like, they even had a Spanish Ace Bright server specifically for Spanish speakers, because they just don't understand English. That is the issue. And when you were playing like old school MMOs like Ragnarok, I mean, the whole issue with the Brazilians was that they were just kind of, and Russians, was that they were just basically bots. Because you can't communicate with them, so you can't play with them. And they can't play with you, so they're just like running around and just like stealing all your mobs because they don't give a shit, because they can't talk with you anyway, so who cares? But yeah, they do have that favela grind set for sure. When I was playing Tree of Savior, the Russians that didn't speak English, they were probably the most hardcore players in the game. They even like patched in Russian characters into the game so that they could read. and everyone, they could even send Russian characters over the text chat, but the default client couldn't support it. So whenever you had Russian people in your party, they would just keep typing dots, like dot 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 dot. and for the longest time, I just thought that they were like super annoyed with you. They were just like dot 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 whenever you said something. They were actually typing in Cyrillic that didn't show up. And they would steal your mobs all the time. Oh boy. So, now we need a struct here called a brick. Brick map? I don't really know. Should I just call it the brick? I think so. It's a brick. It's a map of bricks. And the brick, what should it contain? It should contain a uint house index. I think. But I also want it to contain... You can't have a boolean here, I think. Or maybe you can. Let's see. Actually, you probably can. Cool. I call it. Has content. Doesn't matter really. Let's call it is empty. Because that's what we want to know. We want to know if it is empty so we can skip it. And then we need a struct house. And this one doesn't need an index, it just needs bool is empty as well. So the idea here is that instead of in the shader, when we're ray tracing, calculating which brick we're in, which voxel we're in, which house we're in, instead of calculating that every single step, all we want to do is we want to find out where we are, like which brick am I in, or which voxel am I in, or which whatever. And if you are in a voxel, then you want to check if the brick is empty. Or when you enter a new brick, you want to check if the brick is empty. But when you're traversing the voxels, you have to be able to check which brick we're currently in. And what I was doing there before was I was just checking our current voxel position, and I was dividing that by this and that, and multiplying this by that and that. And that's what I want to avoid. So I want the voxel itself to just have a number, and it says I'm in, this is brick index 3, for example. And then you just go and check brick 3, and that's it. Because the ray tracing itself is already extremely heavy. So I don't want to add things to it to make it heavier. So I want to do as much as we can on the CPU now. So we want to, for once, instead of offloading from the CPU to the GPU, we want to offload from the GPU to the CPU as much as possible. So why do I even need this bit mask in that case? The whole point of the bit mask was so that we can tell if the brick has any voxels that contain anything or not. But there was a paper. Let's see if I saved it. Fast voxel traversal algorithm. No. Dynamic deep octree for VR painting. No. Is it this one? Yeah, it's this one. So what they have here is they have 512 bits here. And then they have a color pointer and they have an LOD color. But what does that add up to? That's too much. Isn't it? At least for this system. 512 bits. Divided by 8. That's 64 bytes. That's 64 bytes and we multiply that by 4, we get 256. But what am I thinking? I don't know how I came to the conclusions I came to before. You've got 512 bits, 32 bits, 24 bits. If you take 512 and divide it by 32, you get 16. So then we have 16 units. We're not even near the limit. Somehow I had convinced myself that we were at the byte limit. The 16 times 32, that's 512. And then we have 32 plus 24 there, divided by divided by 8. That's 7. So we have 16 plus 7 bytes. That's 23 bytes times 32. No, times 4. No. The data structure consists of exactly 71 bytes, not counting shading attributes. Yeah. I don't really know what they're doing with the color pointer and the LOD color, but I think you have to take this paper with a grain of salt too, because the whole point of this system is this, editing large voxel scenes, because they're making a painting system, so you can like draw in VR with a VR brush, and it gets updated instantly. And that's not what I'm doing, though it could be still a useful thing to do. But this part here, where they have like a color pointer and an LOD color on the brick itself, I don't know if I necessarily need. But I'm not sure. I think I do want LOD on the bricks, but I'm not entirely certain. It would be cool, because that would mean I could have really, really, really large draw distances, but it depends. Because I've seen people do it, and I've also seen people say that it doesn't make that much of a difference. It's important that you don't use too much data, because the GPUs only have so much memory, right? So we can't just keep infinite amounts of voxels on them. The voxels take up a lot of space very quickly. Like, if the voxel contains... Let's say it contains two variables. It contains a color index and a brick index. That's two integers. So that's gonna be 64 bits divided by 8. That's 8 bytes. And then that's 8 bytes per voxel. And then we have... What's my current draw distance? My current draw distance is 32 times 8. That's 256 times 256 times 256. So we've got 16 million voxels times 8. That's 134 million bytes. So that divided by 124. Oh, let's just do this. 134,000 kilobytes, 134 megabytes. So that's not that big currently, but the issue comes once we want to have more things in there too. And if we want a larger draw distance, because that's how high I want the world to be. And there are multiple reasons for that. Or what you can do, if you have a world that has a limit of 256, then you can use height maps for a lot of things, and that's what I want to do. It's very important. Because then you can, for example, if you're doing light and you're doing light rays, all you need to do is, instead of once you hit a block with a ray, you have to then cast a ray to the sun or whatever other light source you have, and instead of stepping all the way up to the sun, which is outside of the map, you can just check your height map, and it says, yeah, we're already at the highest point. There's nothing that we can collide with. Then you just skip the whole ray tracing step, and that will greatly increase rendering speed. And a color is, well, you can technically, well, no. Well? A color channel is generally 8 bits, and that means it has 256 steps. So if you want to use one color channel, because that's the easiest way to do it, that's how you do it, right? But I don't know if there are other color, like there might be other color color formats. Like maybe there's a 32-bit black and white or something. I wonder. public texture 2D height map. And then we just try this height map equals height map dot format equals new texture 2D 0 texture format dot. You have alpha 8, ARGB 32, ARGB 44444, that's 16 bits. Compressed RGBA, DXT1, compressed color texture, DACR, 4 bits pixel compressed unsigned single channel texture format. R16, single channel R texture format, 16-bit integer. Yeah, see, that's what you can use. So I'm surprised it doesn't have a 32 bits. RG32, 2 channel, 16-bit. R float. There we got one. Scalar R texture format, 32-bit floating point. Alright, then you can make a texture that has insane depth in even one channel, perhaps. So you might not need a 256 height limit, but I still think it's a good limit, I think. Because it depends on what you want to do with the height, right? Like, maybe you want people to be able to build super high stuff or whatever. But if you don't, then you don't need the height. And it depends on how much you want people to be able to dig, like how much is that part of the game. And it also depends on how tall do you want mountains to be able to be, for example. And what would it look like in practice? It is a little bit tight, I feel. Like, if you want some depth here, because here it would be like 50 deep. Let's take a little look here. How deep are oceans? Average depth of the ocean is about 3,688 meters. And then we have mountain height average. Highest mountain, 8,000 meters. Big, like 4,000 meters. It's pretty normal. So that's like an 8,000 meter range. I don't really intend to have like sea depth that matters. I'm just trying to think of like, what would you actually have and how would it feel? Like if you have this, so you have a maximum world height of 256 blocks. That would basically mean that your mountains are 256 in height, exclusively. Which is kind of lame, right? But even if you like double this, it's still not gonna be that high. So I don't think it's a proper solution to just increase it. Because you still need to have rendering limits, otherwise it's just not gonna work. One thing you can do is, but that logic seems difficult. Because what you can do is you can you'll split the world into chunks anyway, right? But what you can do is if you want to have a mountain like this, that's a mountain, very beautiful. Is you can do this, basically. Like that. And then up here, it'll look more like this, right? So you offset your chunks so that you have a different maximum height here, and here you have a different minimum depth. So you'll basically hit bedrock or whatever you want to call it here. And if you were to build, you would be able to go up here. And that way you can generate mountains that are any height. But it becomes really weird with the logic of like loading it and traversing through it, I think. But it is doable. However, it means that you won't be able to like dig under a mountain, for example. Because if you've got a world, even if you don't load all of it into the GPU, you still have to store it somewhere. Like, you still have to store it on the computer. And even more so if you want to... If you want to have online play, you have to be able to send the area to people as well. So just having like infinite amounts of voxels is just not proper, I think. But I would like to have something like this. Like, I do need to think of or choose a solution that lets us do something like this. Because I don't want to just have pathetic 200 meters tall mountains and that's it. I do want to have proper mountain areas. But that's a problem for another day. Now, I'm a little bit confused. Brick maps encode solid data in a bitmask and store colors separately. They are small and can be stored in high numbers. Brick maps are stored in the brick grid, which is a uniform grid spanning the entire draw distance. This grid contains pointers to brick maps. Figure 9 shows a brick map as a blue grid contained in the brick grid as a red grid. This data structure is already capable of efficiently representing a large voxel world due to the sparse storage of brick maps. Brick maps are the core of our data structure, and together they form the actual representation of the data. We empirically determined a good size for the brick maps to be d to the power of b equals 888. Since brick maps represent fine detail, which can be random in nature, the size of the brick map is equal in all dimensions. Given this size, 512 bits are required to represent the solid data of the brick map. Altogether, the data structure consists of exactly 71 bytes, not counting shading attributes. The exact layout can be seen in figure 10. We store shading attributes such as color separately because a relatively high number of voxels are empty and have no shading attributes. Instead, the brick map contains a pointer to an array where these attributes are stored. The color pointer is the pointer to the voxels. That's what the color means. Color doesn't just mean color. It literally means this is the voxel data, because that's what they're doing. They're painting using voxels, but the voxels are not textured. They're just colors in their case. And what that means is that this is just the voxels. So and the LOD color, that's gonna be, it's just a RGB color that they store, right? I think. That's why it's 24 bits instead of 32, because they don't need the alpha. But see, the thing that's odd that I can't really wrap my head around is they're trying to like let's read this here. Finally, the brick map data structure contains a level of detail color which is used in case the brick map is out of LOD range. Every cell of the brick grid contains a pointer. A pointer either points to a loaded brick map, an unloaded brick map, or is an empty pointer. If the pointer is empty, the corresponding brick map is also empty and no additional data is required. For streaming and editing purposes, the grid cell can contain a brick map which is not yet loaded into GPU memory. In this case, the first 3 bytes of the pointer contain an LOD color and the last byte contains flags to determine it is unloaded. Alright, so how long have you been working on this ray tracing for? I don't know. Less than a month. I started trying to figure this out around after Christmas. But it's pretty tricky. Actually, getting the ray casting to work was really easy. And that's not the issue. The issue is all of the techniques to speed it up. That's where I am struggling right now. And I have gotten that to work as well, but not well enough. Because ray tracing is super slow. Because every single step of the way you have to check every single voxel, even if it's just... even if we cast this ray and there's nothing. Like, all the way from here to here, the edge of the map, there's nothing. It checks every single step of the way, and that's what I'm trying to get rid of. So what I did was I implemented like large sections here that just says that it doesn't contain anything. And that means that it can skip that whole segment in one go. Or in much larger steps. And I got that working. But it was super hard. And then I want to implement an even larger step that's like this big. So that it'll skip it in 2 steps, more or less. And that broke everything. So now I'm trying to rethink it a little bit from the ground up. Or rethink it the way it's supposed to be, or was supposed to be in the first place. We're revisiting the paper on it. This part might make sense later, but right now, not really. Like, the first 3 bytes of the pointer contain an LOD color, and the last byte contains flags to determine it is unloaded. And that means that if it's unloaded, that means it exists, but it hasn't been loaded in yet. And then, because it's not loaded in, it'll just render the LOD color. So it'll just be like a giant green block instead of being the proper voxels. And that might make more sense later once we start properly either generating chunks on the fly as we're walking around, or just like loading them in as we're walking around from disk or something like that. Because like maybe we're moving faster than just the loading allows and stuff like that, and that'll handle that to some degree. But I don't understand this empty pointer thing. If that just means that we're like outside of the canvas, kind of. Because I don't understand how something can ever be empty. In that sense. And even if it's empty, I don't see how it doesn't take up memory. Brick maps are of constant size and stored in a simple object pool. The CPU keeps track of this pool, and any allocations are sent to the GPU as an index in the object pool buffer. Allocation and deallocation are then done in 0, 1, in O parentheses 1 time, without any memory overhead. This simple yet elegant solution is trivial to implement. For color data, a more complex system is required, as color data is of dynamic size depending on the number of visible voxels in a brick map. We use a memory allocation scheme that stores memory nodes at different levels. Every level has a different node size, and on allocation we remove a node from the lowest level with a sufficiently high node size. This system allows for fast allocation and, in the worst case, deallocation, where F stands for the number of free nodes at the corresponding level. Blah 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 blah. Editing is done on the CPU, which then only has to send information to the GPU telling it which brick maps are out of date. The brick grid pointers are then set to unloaded, and the streaming system will take care of the rest. Since color compression and the visibility tests are done right before uploading, the CPU only needs to worry about memory management. When updating a brick map, the brick map object pool pointer and color data must be freed. Since these operations are fast, editing is easy and allows the user a lot of freedom. Ray tracing is performed using a 3D DDA grid traversal on each level of the hierarchy and terminates when a solid cell is encountered or the ray leaves the grid. Ray tracing a brick grid works by first calculating the initial cell hit, which is determined by discretizing the intersection of the ray and the bounding box of a grid. After finding this cell, we progress through the grid by comparing the intersections between the ray and every face of the current cell. We then change the current cell depending on the face we intersect first until a cell is either solid or out of bounds. Since faces are axes aligned, it is straightforward to calculate the intersection point, and the cell index corresponding to that axis is modified. Ray tracing a grid. Red bars represent faces passed through, the cyan dot represents the initial entry point of the ray. I mean... I think this is basically what I'm doing already. The only difference is that this might arguably be a bit smarter. Because once they enter the brick grid, or the brick itself, they are like internally just keeping track of bounds, because I was checking every single step and with a division, like am I outside, am I outside, am I outside. So I'm just thinking, like, maybe a while loop within a while loop could be better. Because that way, if you find a grid or a brick that you need to enter, then you could set like a map position limit right away, and you could just be like, while map position X is less than this and map position Y is less than this, then we loop. And then it just goes through a couple of steps until it's outside. But otherwise, I don't know what this means. Discretizing the intersection of the ray. What does that even mean? Discretizing, meaning discretizing, representing or approximate using a degree of quantity or quantities. I don't like this term discrete, it doesn't mean anything. Looking at math on Wikipedia is a big mistake. But it's basically what I'm doing, I think. We're just taking the ray length and we're recalculating the ray position that, and it should be fine. And I mean, it is fine. We have literally always already confirmed that it works. But now, this kind of bothers me. But I guess technically, I don't know if it really matters, because solid mask. I'm just trying to think of why I need this. Like, actually, why do I need this? Because the only reason to have a solid mask, right, is... it's so we can check the current voxel position. But we don't want it for checking if the brick is empty or not. So... well, I don't really understand how the mask helps me at all. Because it's just tedious to check it. Because the way I need to store the bit mask is with uints. Like, there's no other way to store a bit mask. I need 16 uints, and there's like no logical way to access this without doing a bunch of math. Because we need to figure out which int are we in, and to do that I need to divide the voxel count, or the voxel index, by 32. That way we get which int am I currently in, and then we need the remainder, because if it's like, if your voxel index is 34 and you divide it by 32, you'll get a decimal value, and that decimal value will tell you which bit inside this this integer you're inside. And then you can check your bit. But I don't understand the point of this, when I could literally just store a boolean on the voxel itself, and then I can just check the voxel, is this solid, yes, no? Or just literally just have a color. And the color is like, it's not a color pointer, it's a color index. So it's just gonna be, this voxel's color is 0. That means that it's empty. And you don't even need a boolean, you don't need anything, because you already have that. So, like, that's what I'm really confused about. So I think instead of bothering with this mask bullshit, it does serve a purpose though, but it doesn't serve a purpose here. It serves a purpose on the CPU, because there having the bit mask would make it faster to check the brick. Because otherwise, every single time you edit the brick, you have to determine if it becomes empty or not. Or not every time you edit, but rather every single time you remove something solid in the brick, you have to determine if it becomes empty or if it has something in it. Because if it has something in it whatsoever, it needs to be traversed. But if it has nothing, then it can be skipped. And the thing is, if you remove something and you don't have a bit mask to check, then you have to check every single voxel. And that's 512 iterations in a for loop. But if you have a bit mask, then you can just do 16 checks, because all you have to do is you have to check, is this thing 0, 0, 0, 0, 0, after you changed that one flag, and then it's fine. And you can also on the CPU you can use, I think you can use bigger bigger integers too. I know there are. I don't know if there are any problems with them, but I think there are like big int libraries, so you can have like 128-bit integers, and that way. I don't know if it is a legit way to do things or not, or if it'll break on like other operating systems or CPUs or whatever. I don't know. But what you really want to do is you just want to check is the integer 0 or not. And I'm just thinking like the bigger integer you have, the less work you'll have to do. And if I could have a 512-bit integer, like that would be it. You can have an array of bytes. That might make more sense than having it stored as 32-bit integers, because the problem there is that it doesn't make sense. But if you have a 64-bit or 64 length byte array, then all you would need is like well, you still need to calculate the y and the z, because it's still gonna be like it's gonna be y plus z times length, and then that's which byte it is, and then the x is which point in the byte it is, or which bit it is. Big integer from .NET. But I think an array of bytes is probably the most logical way to store it for saving and loading too. And that way we can use the bit mask exclusively on the CPU and not do anything with it on the GPU. Until I understand why the hell I would want that, because I don't understand that at all right now. It makes no sense to me why I would bother with that. think I've been misunderstanding, actually. I don't think that this that they're talking about, this mask, color pointer and whatever, I don't think this is talking about how it's stored on the GPU. I think this is literally just how it is stored as data at all. And I think that's where my confusion has come in, that I thought that this was how they stored it on the CPU or on the GPU, or how they transferred it wholesale to the GPU. And I don't think that's the case. Oh, Shemi, nice of you to say something for the first time in your life. Go on. Why do you have Prime Gaming? That is true. So basically, we need to go... Love the idea of the stream? Yeah. I'm new to streaming. I've never done this before. So let's change this class. So I want to store it as a class? Is that what we want to do? We already have something called a voxel. Where? There, that's our voxel. It's a struct. How's it going, Shemi? What are you up to? Yeah, I didn't know you know any programming at all. But yeah, the struct is a data type, while the class is a reference type in C#, which means that if you have a struct, and you want to like set it somewhere, it'll copy the data over, etc., etc. And what I noticed in my other project, where I check through the or I read the tiles a lot in a 3D array, was that the struct was way faster to like iterate through and such. So it might make sense still to keep them as a struct. Unity uses either 4.7.2 .NET Framework or .NET Standard 2.0. You can choose. But I think it actually uses the newest one. It's just that when you're inside Unity and you pick, it says like .NET 4.7 whatever, but you can use like the absolute newest versions, I think. But I'm not entirely sure. It's kind of strange. Yeah, they default to standard 2.0. But I don't really know anything about either, to be honest. But so we've got these voxels. Now, what does a voxel need to contain? For now, I think the voxel literally only needs to contain its color, which later on would represent a texture, of course. But we'll get to that later. Framework used a runtime like Java, so needed a runtime install. .NET Framework Core is more Python-y. I don't know what that means at all. I never used Java or Python. I'm basically strictly a Unity C# developer. I want to try learning Rust, but it's such a pain in the ass to develop like the rendering steps, and I've never gotten past that yet. So I want to just do some fun stuff for a while after we get past this. But the voxel needs color index, voxel name, yeah, okay, I remember what this is. This is like where I was setting the voxel types. But all it needs is a color index for now. Now, we've got a brick map here. I don't know if I even want to use this. Maybe I do. Got a bunch of functions, clear voxels and whatnot. Yeah. I usually just comment things out for ages, but originally, like, the whole core of this system is using sparse volume or sparse volume data structures, and that basically means that you've got like large sections, and then you set them as like this contains something, this does not contain something, and that means that you can just skip reading every you don't have to read anything inside it if it doesn't contain anything. And that was basically what this whole thing was. I don't know if I need all of this. But before that, I was trying something called an octree. And that works similar to a brick map. But the octree is, or a quadtree, is just like a square. And inside, you've got 512 voxels, let's say. But then, if you ray trace through it like this here, you can then split it like that. And then you can check, okay, does this contain anything? And if this is no, then you can just keep going until you come here. And then this is like, yeah, there's something in here. All right, then we split it again. And then it checks, is there something in here? And it's like, yeah, there's something in here. All right, let's split it again. And then you're like in here and it's like, yeah, there's something in here. And then you split it again until you get to the like lowest level where the voxel data is contained. And for that, I needed a lot more code to get that to work. But now I'm using a brick map, and a brick map is the exact same thing, except it's just one big square. And if you go into it, you're like, does this contain anything? And it's like, no. Okay, then you skip the whole thing. And if it contains anything, then you just go straight down to the voxel level right away and you just start looking. I just don't know if I really need all of this crap. Still need it on the CPU side, I think. But this is like mostly helper functions anyway. It's like we're gonna set a brick or set a voxel or clear a voxel. I picked diagnosing heart disease using sounds in C# and my intro was figuring out the web files and using fast Fourier transforms. Yeah, I mean, it's not like I'm new to C#, but I am new to ray tracing and all of this. Our other project is quite far along, I think. Also, I haven't slept for 2 days until today, and I'm a little bit groggy. Like, not sure what I'm doing. As soon as I get some free time, quitting my job. Yeah, I mean, making video games is really easy, to be honest. It depends. It all depends on how complicated shit you want to do. I quit. Yeah, I remember you were saying something about that. I don't know if I saw why, though. But I can imagine pretty much any university environment isn't very enjoyable anymore. Workload and money. Okay, so it's just normal reasons. Yeah. Okay, so let's go with this. Let's say that this is our brick. I want to rename it to brick, specifically a brick. And It's got a bit mask array of units, but I want that to be bytes, I think. We've got a byte array of 64, right? Yeah. And does the brick need to contain its position? I don't think so. Like the way having a position was like kind of okay. Because what you could do was you could just feed a float position into the brick map, and it would just give you which voxel you're pointing at. But I think it just bloats the data, because you do need to store this. So I don't think we want that. Bit array. That was something I was trying to do something with. Let's get rid of that. Bool has content. Side length, we don't need that. Voxel array, the brick. Yeah, sure. Let's have it contain a voxel array. In Minecraft, what do they call a chunk? Or how big is a chunk? Is it just 8 times 8? Minecraft chunk size 16 blocks wide and long. But a Minecraft chunk is also 364 blocks tall. So how big is that actually? 16 times 16 times 384. That's 98,000 blocks. So if we have a brick, that's 8. But if we have what I call a house, or maybe I should call it a wall, then we have 64 blocks in one axis. So if we take 64 times 64 times 64, that's 262,000. I wish we were in scientific mode so that this remembered things. What did I say? 16 times 16 times 384. That's 98. Because what I'm thinking is, I'm trying to implement a larger sparse data structure or data volume on top of the brick map. Because even with the brick map, it's only 8 times 8 times 8. So whenever we're raycasting to the sky, it takes forever and it uses shitloads of processing power. So I want to just have a huge structure that we can skip. And that's purely for the sky, nothing for the rest. But what I'm thinking is I have to load things, right? And I feel like whenever we load or we stream in chunks of like terrain data, that has to be done in the largest structure size. So if I want to have a very large section of space that we can skip, that's the section that has to be loaded in whenever we load things in. And I'm just worried that if that's too big, then that's gonna be really heavy to load in, and it'll also be very noticeable as it gets like popped in. And And 64 voxels in view distance popping in is probably a lot. I'm a little bit worried about that. But it doesn't have to be that big. There's no reason for it to necessarily be that big, except for it making it... Because, you know, the bigger it is, the more space we can skip. Because here, when we're ray tracing, right? A brick only skips this much space. Takes guts to show your code base to the world as you code. Well, I mean, it doesn't really matter, to be honest. Like, what are they gonna do? Are they gonna steal my code? Maybe some Russian's gonna steal my code. Props to him if he manages to piece it together from like 60 million streams. That does happen sometimes. There's programmers have a tendency to be extremely autistic. And they'll be like, why are you doing it like that? And it's like, literally, why am I using like an integer and I'm like multiplying instead of like, why am I not like bit shifting it or something? It's like, I don't know, so that it makes any sense, I guess. It happens all the time, but it's not that big of a deal. But yeah, this is what I want. Here we're skipping 8 times 8 times 8. And as you can see, if we're standing like down here, even with brick maps, it's still like 20 steps, at least, just to see that we're outside of the world. And that's why I wanted this to be bigger. So if this is 64 times 64, that's how big it would be, right? Yeah. Then we've got much larger segments. But how big would that be? This is 64 times 64, and our view distance wouldn't be that massive, I imagine. It would probably be around this. And that's why I'm worried about having such a large structure or section being like our basic size for loading things in. because it might not work very well. But it depends entirely on how much better the ray tracing works after we get rid of all the junk calculations I'm doing in there, because they do matter a lot, I think. Not doing 60 million modulos and like 400,000 divisions and multiplications just to get every single index that's worth tracing should make a big difference. So we might be able to do bigger. I think right now I'm actually doing more like this. In view distance. And it might be okay, I guess, for it to like pop in. I don't know. Let's just go with it. Let's just have 8x8x8 brick maps for now. Why not an existing Unity voxel engine versus from scratch? Because there isn't really any. Like, no, but there's... Yeah. I mean, you can do it. Like, there are plenty of people who are doing voxels, but using other people's stuff is just weird. Like, if you want to even understand the code, it takes forever to understand it. Half the time it's gonna be like proprietary as well. Like that's even an issue with Unity itself, that everything is proprietary. So if you have an issue with anything, like the renderers or whatever, you're just out of luck. You can't do anything with it. You have to like literally wait for them to fix a bug or whatever, or just find a workaround. And I'm making a ray tracing renderer. Like, it's not a normal renderer. It's using ray tracing exclusively to render. And in the voxel communities that I'm in, the most popular way to do things is still meshing. Like, you just have voxel data, right? And then you just create a normal mesh based on that. And then you do some optimizations like greedy meshing to have less triangles, and then you just render it normally. And if you do that, you can probably find something, but again, just using other people's base is plus most of other people's bases are shit as well. That's also a big problem. Because you can find engines for almost anything, but they're all shit. To be perfectly honest. Unity's built-in prototyping things, also shit. I don't know if you tried Valheim, but Valheim is purely made using Unity prototyping features, like Unity's terrain system. It's using Unity's physics system, it's using Unity's lighting system, etc, etc. And they did pretty well with what they have, but they literally can't do anything more with the game. Like, if they want to improve anything in the game, they have to literally just rip out Unity's systems that they're using and just completely from scratch replace them with their own methods. That's why you can't dig caves and stuff, because they're just using Unity's terrain system. And Unity's terrain system, it's literally just a plane. And then you just modify it in height based on a height map, and that's it. So you can't like put holes into it or anything like that, other than just making it higher or lower in sections and such. And yeah, and it's also why there are no real like water mechanics. The water is literally also just Unity's terrain system, but it's just, they have two terrains, and the water is just kind of placed at a certain level, so that's why you can get like waves that just show up and come up into it like from nowhere sometimes. Example. So yeah, if you want to do something a bit more, then you just have to write it from scratch, because let's see. Like there are some devlogs on YouTube that show pretty interesting things that I would like to mimic if possible, but I'm not sure it's doable in Unity. Because from what I understand, C# is pretty slow. And the problem with Unity's rendering pipeline is that it's all proprietary, pretty much. But yeah, that's why I have been thinking about learning or trying Rust, because apparently Rust is a lot more understandable than C++. C++ is like 2 years minimum to learn it, but Rust should be a lot better. And from what I've heard, Rust is only like 0.4% slower than C++ as well. But you also have to learn like Vulkan as well. And Unity kind of takes care of a lot of the back-end stuff for the rendering. I've talked to a lot of people and they say that Rust is good. There are some pretty interesting devlogs. I can't really remember what they're called. Oh, you got John Lynn. Got a pretty neat voxel engine. Everybody talks about John Lynn. Because you see, everything here is a voxel. Like the flowers are voxels. Like they're all constructed from voxels. The trees are all voxels. If you look at all of it, and he can just go into the trees and just like chop it up if he wants. I don't think he does that in this video though. And as you can tell, the voxels are tiny, which is also pretty interesting. I don't know how he fits all of this data. That's kind of interesting. Nobody understands how he's done any of this, by the way. But this is done with ray trace rendering. Because otherwise you just can't do this with meshing, it's impossible. Bjarne Strostrup. Got a bit annoyed about Rust is safer than C++. Oh, well, I don't even know what coding safety means. I'll save it as a bookmark. I don't like reading, but we'll put it there. I have a lot of stuff I haven't read. Anyhow. The brick. Yeah. Yeah, I don't know any of that, but they were talking about that earlier in the Voxel Discord server. A little bit. And It just seems like there's 100 million different ways to do things that are bad. And in C# you just can't do anything that matters. That's bad at all. Like, you literally have to go in and enable unsafe code to be able to do anything that's bad. But, should this also be a struct? You don't have position anymore. Whatever. Get index from vector 3. Yeah, that's what I was thinking. Let's just comment out everything that doesn't feel like it makes any sense. This is... Where did my music go? So many of these songs that I downloaded are just shit. I'm gonna switch back to just listening to the Breath of Fire soundtrack on loop again. There we go. Alright, dude. Well, drop by some more. It's nice to talk when it's not just constant banter. Good luck with your marking. Don't need luck, I need a miracle. Clear voxel. I don't have any autism. That's my problem. I'm not autistic. I'm not. I'm genuinely like the least autistic person ever. That's the biggest problem. That's my weakness. That is it? Not being autistic? Is B something? How do you just write a byte? How do you write byte? Like, you can type like one U for a uint, you can type .f for a float, but I don't know if you can just say one byte. 1B isn't a thing. You can type it like this, B 0B underscore 000 or underscore 1. I think that's literally a byte. Yeah, that works. No, wait. The bit mask array, that's a byte. Oh, okay. The bitwise are all they're all integer operators. That's kind of sad. That'll make this weird again, though. That's making me sad. Okay, so basically we want to store this as integers now. Int. Whoa! Yeah, well, we've already given up on bytes. The problem is that storing them as bytes made more sense logically for accessing them, because when you're storing things as 32-bit integers and you want to access blocks of 8 bits, right? It becomes really weird when you want to access like the third bit in a or the third block inside of a uint, because you have to do a bunch of divisions and shit to get the right index. But the C# bitwise operators don't work on bytes, and it just ends up being an integer anyway, so. But apparently they're telling me to use casts, so maybe it's not that big of a deal. Because it's like, either we deal with casts or we deal with divisions, so... You got slides even? Damn, how many bookmarks have you got on this? Ban? Never heard of that before. Span. Barely get it. Go mark your stuff. I'll be fine. Don't worry. You're not unemployed yet. Clear voxel vector 3. We don't want that. Set voxel though. Here we've got something. Side length. Float size. But it doesn't need to have size, because we always know what the size is. It's 8. We don't need this crap. Set voxel. 8, 8, 8. Isn't there like a truncate? No, you just have to floor it. But this is set voxel based on position. I don't really want that either. Convert index to 1D. Now that, on the other hand. Okay, so now we want an index here, and the index is going to be y plus z times 8. And that's it. We don't need any of this crap. We don't need a remainder. We need a bit mask though. I don't know what's going on there. So here now we're clearing this voxel. Well, no. Because we know that what we're clearing. So what we need to do here is... we set a bit mask that's just a full uint. But now we're just flipping a byte. So a full byte, that would be 255, right? And so we just do that, then we'll flip something inside this byte. Now, this could potentially flip it so that it has something in it. No, it can't. That's what we're doing here. We're setting a full bit mask, then we flip one value, and then here bit mask index and one x equals one x. So we're checking the array, and we're getting... yeah, we're checking if the... we're checking if the bit we're trying to check is true. And then we do index, and then we flip. There, that. I'll be right back. What's this check bitwise? Why am I doing that there? Yeah. The code could just be and equals byte minus 1 shifted by x. What does that even do? Okay, so you can... If you do that, if it's negative, then you flip all the bits. Bitwise complement operator. The squiggly line operator produces a bitwise complement of its operand by reversing each bit. And now they're all arguing. This is what I love about programmers. They'll be like, why are you doing that? That's so weird. Do it this way instead. And then there's like 6 other programmers who chime in instantly and they're like, no, you can't do that. And they all start arguing instantly. Oh, Tulip, how's the progress? Terrible. I like ripped out half of it and I'm basically rebuilding the base. Ooh. Once I got to the last step where I was trying to make like bricks of bricks, things started to kind of fall apart because the basis or the base it's resting on is just not strong enough. Because what I was doing in the ray tracer was I'm doing buttloads of calculations every single step of the way for everything. Like just here, just checking a voxel if it has content at all is this. Like just checking a voxel is position modulo 8, position modulo 8 times 8, position z modulo 8 times 64, plus position x divided by 8, plus position y divided by 8 times brick grid size, plus position z divided by 8 times brick grid size times brick grid size times 512. And then it goes in here and you take that index divided by 32, floor it, floor this subtraction, multiply it by 32, and then there's a bit thing here. And this is just not holding up anymore. So what I'm trying to do instead is I'm trying to do all of this on the CPU. So instead of checking through like a bit mask on the GPU, what we're doing is whenever we place a voxel inside of a brick or inside of a big brick, we just set it as this is... It has content, so it's literally just a boolean. Like, this is content. And that's it. And on the C# side, whenever I clear a voxel, I flip a bit inside the bit mask, and then we just check the bit mask or the whole bit mask, and if it's empty, then we set the flag to 0. And instead of having all these index calculations, I'm literally just setting this voxel belongs to brick 2. So then here, when we're ray tracing, instead of having to calculate which brick we're in, it's literally just gonna say in the voxel, this is brick 2. And then we check brick 2. And we see, does brick 2 have any content? No? Then we skip it. So I'm trying to remove as much as possible from the GPU here. So that it can just handle ray tracing. The surface area heuristic for KD tree today? No, I don't know. I'm sorry. I don't even know what a KD tree is. I know what an occ tree is, and I know what a brick map is. But I don't know what a KD tree is. What is a KD tree? I also don't know what a heuristic is. Sorry, I'm not a good programmer. What the hell is this? Breath of Fire 3 commercial song. Oh, nice. Delete. Bitmask array index. What are you saying? What, just if bitmask array index and equals bitmask? Well, I mean, that's what we're doing here, right? Helps you find the best split plane, so your tree is balanced. I don't know what that means. When I was drawing the occ tree, I was literally just using positions and just setting each node of the tree to just have its own position, and I was just doing like lesser than and bigger than AABB checks. Well, it's used twice, so we'll keep that. So is it... That's not the same index. Were you doing raycasting with Octree? No. But I did start just trying to figure out the Octree, but I was literally just writing C# code for like an Octree. And that was it. I didn't try raycasting it at all. I read a little bit about it, and I also talked to some people, and they said that the Octree has some issues when it comes to raycasting, because on the C# side, as just like a data structure, from what I understand, it's easy to just check an index, right? You don't have to traverse down to the bottom just to find an index. If you have a position, you can literally just go in and just you just check that index, right? But when you are using an Octree as a data structure on the GPU, you basically have to use indexes or indices as references to each other. And at that point, it becomes like you literally have to travel from the top node down to the bottom node every single time you want to access something. And from what I understand, that ends up with so many steps that it usually isn't any better than just a normal brick map. Because the main problem isn't really... It isn't really terrain. So, like splitting voxels into terrain, or splitting it like that with the Octree, I don't think it necessarily helps that much. Because what the brick map does is it helps you just cull like the sky, and that's why I'm trying to add another step to the brick mask that's just really big, just to help with that. But raycasting around anything that has terrain, I'm not really sure it matters that much. You'll just end up with a bunch of steps anyway. But I don't know, I'm just guessing. I don't really know. It feels right. I mean, I should be able to add textures later. We can figure out where we are based on the ray. As long as you have the ray distance, I think you can figure out where you are. To get a UV on the voxel, but for now I'm happy with just getting colors. I'm happy with it just rendering properly, so I haven't really thought ahead that far yet. Set voxel. What the hell is going on here? Oh, you know what you can do? We can just use modulo in here, right? That way, we don't even have to take into account which voxel or which brick we're in or anything like that. We can literally just do... let's see. Our index is y modulo 8 plus z modulo 8 times 8. That should just be a normal int. And then we don't need that. We need to set a bit mask array there, and then it'll be just index. And that's gonna set this times x. That's just it. That's all we need. And then we don't need to check bitwise here. What we need is as content equals true, because this is inside the brick. And then our voxel array index gets set to the voxel. Should be fine. So this needs to be x plus index. Well, no, this index doesn't make sense. Not for that. This index makes sense for the bit mask array. But can I just multiply this by 8? I think I can. Because let's do a little test. Let's say Fuck's sake. Let's say we're setting x equals 2, y equals 15, z equals 12, or whatever. Now normally I would write this as 2 plus 15 times 8 plus... Well, first of all, this is a modulo. Modulo 8. 2, 7. And that'll be 4. So then I'd write 2 plus 7 times 8 plus 4 times 64. Two plus 7 times 8 plus 4 times 64. That's 314. That sounds right. So, with our index here, we get 7 plus 4 times 8. That's 32. No, 4 times 8 is that, and then we have plus 7. So that's 39. And then we do 39 times 8 plus 2. 314. That's what we had before. So yeah, we can use this index times 8. So that's good. So the x here also has to be modulo 8. And the reason I want to do that is so that we can just well, I don't know if this will make sense. Actually, we might have to remove this, but I have to do this at some point. Because if I'm just walking around in space and I decide to put a voxel somewhere, that voxel is going to have an index, and we have to calculate which, like, what are we actually accessing there. But I'm thinking, how do you calculate an index? Oh, it depends. Like, if you're storing information, or you're storing voxels, let's say, you can store it in a 3-dimensional array if you want, but you can also store it in a 1-dimensional array, but the data is arranged as it is a 3-dimensional array, so that if you have, say, well, let's just go with one brick, right? My brick has 8 times 8 times 8 voxels. So first you go through the x once. It's literally like a for loop. You go through the x, and once x reaches 7, then y increments once. So then you're at you go back to x0 and y becomes 1. So it works exactly like a nested for loop. Well, it depends, but normally it'll be x plus y times x size plus z times x size times y size, right? And that way it doesn't have to be square or anything like that, but you need to know the length of your y and your z mainly, or your x and your y mainly, because the fact that you've iterated through x once increases y. That means that if you have y1, then that's one row of x's, right? So I think it's called like a Morton algorithm or something like that. And you can kind of reverse it too. And that's why is up. Well, it all depends. That's up to you. But yeah. If you're using like Unity's built-in physics, then yeah, you have to account for that stuff. For sure. And it also depends on if you're even sorting your data in that same way. But that's the base of it. I think I'm gonna go for a walk though. It's been 3 hours and I'm losing focus. I mean, I barely had any focus today anyway, but I'm losing it even more. I'm gonna go to the store and buy some milk in case I want to make coffee more in. So I'll be back in a little bit. Probably won't be that long. Later.
And we're back. That took forever.
What salami? Now the part that I'm not so sure about here. It's really how I want to access everything. Do I just store everything as a house? I don't like that term. House. What should I call it? A wall? Maybe I'll call it a wall. Because I could just store them next to each other, but it's also about the easiest way to serialize it, right? But when it comes to flat buffers, I don't think... Like, I don't know if flat buffers is the best way to do it, but I don't think when it comes to flat buffers that this like nested custom structure is going to work that great. But I don't know. The question is, how does it work? Like, if I want to have a struct on the GPU, if I want a brick struct on the GPU, can I just have like some of these values, or do they have to have the same values? Like, does it have to be exactly the same, or do only the variables have to be the same? Some of them, for it to work. Gosh. I'm just not sure exactly how else
Like, I could... If the voxels was a class, right? Then I could literally just have a voxel array here, and when the brick is created, and but if the voxel, see, this is what's annoying with C#. If you want it to be a pointer, then you have to either turn on unsafe code or it has to be a class. But in this case, it needs to be a struct, I think. I'm not sure we're really gonna get anywhere this stream. Anyone wanna tell me why it keeps adding this? And that? And that? And that? So... God damn it. Voxel type. Well, cool. What should I call this? Is solid. Is content. What else? Something like that. I think that's enough. Need a voxel type array once again. Where's my voxel type array? Because it's not system dot serializable. I don't know why I played it. Voxel types, there. Dirt, grass, is content, 1, 2. Color of grass is green. Dirt is here. Maybe. Bricks. Brick. Alright, should we call it a wall? Let's call it a wall. It's gonna work exactly the same, except for here we're gonna have an array of bricks. And it's going to be called brick array. Then the brick array is going to say new brick. And for new brick, we have to have position, no, fuck you. I'm wondering if I should store the brick and the house as classes. Man, I don't know. And even if it says, like, even if our struct is different, all we need to do is we set the struct on the GPU, and then we just set each variable individually inside. Like, that's all we need to do. It doesn't have to be like equals each other. Just like to set a voxel on the GPU, we don't have to just set it as a voxel. We can just set the variables. It's not that big of a deal. So technically they could all be classes, but again, it's just that it would be good to be able to have references, because I don't know. Maybe it would be fine. Just if I'm gonna like if I want to place one voxel, it'll have to check we are inside this wall, and then check this brick, and then check this voxel just to place it. But each step of the way, we could also just set the variable that we want to set there. Of course, I guess. Because we do want to set that anyway. But we also have to do that in reverse. So it would still be better if I could access the voxel first, then the brick, then the wall. And that's where references come in, because that way the voxel can have a reference to the brick has a reference to the wall, instead of the other way around. Because I have to set, but no, it's fine. Because no, it's fine. It'll take care of itself. Because all I have to do is I have to just say set to the wall to set this voxel, and then it'll go into the brick, and then it'll set the voxel. And once the voxel is set, then the brick will go out and it'll continue running the rest of its method. And the method is going to check the brick. And then it goes out to the house, and the house checks itself to set itself as empty or not. No, it's fine. Just not really sure how I want to do things. And the wall does not need a position. Does not need a byte size. It does not need a length. What does it even need? Here it says that I cannot use parameterless struct constructors in C# 9. And we're supposed to use 10 for that. Can I use 10? C# 10 Unity. Oh, this. Let's go. I don't know what that's supposed to be. A big ball of meat. But I don't really feel like I need any value to it, but I guess we'll just give it a length, just pause. And the brick array gets the same length. The brick needs have the same changes here. Like so. We have a bit mask array, we have a brick array. But see, here is where things get a little bit trickier. Voxel. So do I want to be able to access it like this? Return brick array. So this will be I don't really know Because it gets really, really complicated. I've never really done anything like this, so I'm not really sure. Because oh, whatever. Because the problem is that once you load, let's say we load here. We start with 0 here, and this is 0, 1, 2, 3, 4, 7. There. Now we have 7, or 0 there, and we have 7 here. Now let's assume these are houses, or walls, wall grids. And by that I mean we have voxels, and then we have bricks, and bricks contain 8 times 8 voxels, and a wall contains 8 times 8 bricks, right? So once we load in a new set of bricks, that's gonna be kind of like this. Here's 7, and if I'm moving to the right, then here I need to load in a new set of walls. But what's gonna happen is that we are going to load in 8 here. So now we have 1 there, we have 8 here, and we have 7 there. See how this gets confusing quickly? And that's just moving in one axis. So but technically this will still be 0. It's just that whatever was in 0 is now replaced with whatever is to the right of 7 in the database. So technically this will still be 0. So the question is how to really access that. And I think it's just gonna be a bunch of modulo. And it's gonna be inside the controller where we set. So that's gonna have to be something like public set voxel, public void set voxel. And then it's gonna be We've got bit masks, we've got voxel type array, world gem, voxels. We have public, wall, walls. And walls is going to be our world for the time being. So setting a voxel is going to be int x, no, just do vector 3 int z, or position. And then it needs a voxel. And to access this is going to be not gonna be like that. Voxel x, or position x divided by 64. But there's no reason to store them as a 1D grid. This case. We can have a 3D grid of walls. And then that's just gonna be position.x divided by 64, position.y divided by 64, and position.z divided by 64. That's gonna be walls. Not live on Twitch. See. Looks like it. The one way of doing this is that, and then we can do set voxel position voxel. But then inside the wall, Set voxel. Now if we get this XYZ here, all we get here is a brick. So what we need to do is we need to go to our brick array. This should actually be correct. No, it isn't. It needs to be y divided by 8. Plus z divided by 8. Modulo 8 times 8. And x is also x times 8. Or divided by 8, modulo 8. And then we do dot set voxel there as well. That's gonna set x, y, z for voxel. I believe. Then we go into our voxel. Which has nothing. Well, what did I just do? Oh, it's in our brick. Because the brick contains the voxel, and the brick is going to say... That's a brick array. The brick array can also be 3D here, I believe. Less conversion and crap. That's trying to return a voxel. Turn brick array. Voxel array is also 3D. And then to return a voxel array, we take x modulo 8, y modulo 8, z modulo 8. That's what you get there. And then here, we go in here and we grab a brick, we get that. But it shouldn't be, it should be x divided by 8 modulo 8. Right? No, it should be divided by 64. And y divided by 64. So 8 z divided by 64 modulo 8. And then that returns a brick. I guess I'll just have to do this on the top level. But I could still do, because this will return a brick, and then we can do this, and just do X, Y, Z there too. But no, this should be... This is divided by 8, not 64. Because... I don't know if I should do it like this. This should probably just say get voxel, for example. But get voxel, set voxel, because this might end up looking kind of confusing. Because it's gonna be the wall is going to be a 3-dimensional array, and then you input this, and then you can. This is going to be the index, or rather the position in the coordinate system, just floored to int. That's just how we're gonna place and access things. And I don't know if I want to do it using indexing like this, but it doesn't really matter because it would be the same here anyway. I'm not gonna stream that much longer. I need to make food, though I'm not sure what. I don't know if you can make soup out of ham. Ham soup. Maybe. I don't know what Little Rascals is. I never really liked movies much. I watched like Disney movies, that was about it. I think maybe I'll leave it here for today. I'm not really sure what I'm doing. I'm kind of just trying to set up the data structures on the CPU side right now, and I'm just not 100% sure how it should even be. So I'm kind of wishy-washy, that's why I'm not really doing anything. Because I'm trying to move most things over to the CPU instead of the GPU. Because the GPU is already heavily taxed enough. It doesn't need to do a billion divisions and calculations while it's ray tracing. So it's better that whenever we place a voxel or remove a voxel, the CPU will check that brick and that wall and determine if it's visible or not, or if it has anything in it. And then we'll just send that to the GPU. But it's like all the indices and like the order and of everything that it's kind of difficult to really plan ahead for, because I'm overthinking it a little bit, because we just want to get it to work for a fixed amount of voxels to start out with, and then after that we'll try figuring out how to cycle things out and cycle things in as we're moving around, and we need to generate or load content. But that is the tricky part. Because we're gonna have to do some weird looping math to access the arrays correctly. And again, that's why I'm a little bit concerned about how to really access this here. But I think it's all just modulo. Because basically the further we move to the right, then our original array of walls or bricks or voxels will start getting overwritten behind us. And then once we have moved the full distance away, then that means we just like loop our position back to 0, like we're just coming from the side there. And that just works the same in X and Y, or X and Z as it's gonna be. Because Y is up and down, and those should probably be loaded in. The height should be loaded in every single step of the way. At least for the moment. Unless I decide to make the world higher or something, but I don't think I want to do that. But it all depends on how much actually fits as well. Within like the memory and the performance, but we'll stop there. I only slept for the first time in 2 days, so I'm a little bit groggy. But we'll try to do more tomorrow. And now I'm gonna go and be bored, because I don't know what else to do. So I'll see you later. Thanks for hanging. Bye-bye.